Hello everyone, welcome back. Today let's solve the 33rd top coding into question from 48 top coding into questions created by leetcode. We'll solve this problem using Python. This problem is part of dynamic programming. What is dynamic programming, how it is different from regular other programming, we'll discuss about that. So the problem is, so you have been given stairs, right? You have to climb those stairs. So it takes multiple ways to, steps to reach to the top, right? So when you are climbing stairs, so you can take a step one or two steps maximum to climb each stairs. So if there are two stairs given, and there are two stairs, there are two options. You can go to the top. First option is you can claim the first stair, and then second option is again you first option. In the first option you go one by one, and the second option is you directly go to the second stair, right? Because you have option to climb either one step or two steps. So let's understand this problem. So first of all, let's understand what is dynamic program. So it's basically one of the optimization technique when you are working on recursion. Recursion is something you're calling the same function again and again, right? Repeatedly you're calling the same function again and again. So dynamic programming optimizes that part. So this is the post from Geeks for Geeks. The content is also directly from Geeks for Geeks. So what is dynamic programming is mainly an optimization or a plain recursion. Whenever you see a recursive problem that is repeated calls for same input, so you basically, the idea is to simply store the results, intermediate results, sub problems, so that you don't have to recompute them again and again. For example, let's say this is the Fibonacci series calculation problem. So when you pass, let's say when you pass a number, let's say 5, so you compute the values for 4, you compute the values for 3, and then you recompute the intermediate values. You recompute the intermediate values when you are keep moving, right? So it's a exponential. So here dynamic programming, what it says is you basically store the recomputed values in middle. So what exactly meaning by that is there is one more image. I mean, this is the same version, which is a, here you are calling the same function again, but here you are storing the intermediate values. You are storing these intermediate values in another array, so that you don't recompute them again and again. That is what the dynamic programming is all about. So let's go again to further steps. Let's say with the same problem which we have discussing, right? Let's say there are n five stairs, right? There are 5 stairs you have to climb. So you can climb either one step or two step at a time, right? So let's say you are at the 0 and the n is a 5. 5 times you have to claim. For the first time, when you draw that in a tree manner, right? In a tree manner, in a decision tree manner. So for the first time, you can either go in step 1 or so which is taking one step, or you can take two steps at a time. So again, so when you reach, so basically you have to reach to the 5, right? This is the 5. This is the one way of reaching to the 5. This is another way of reaching. This is another way. This is another way. This is another way. So basically, what it's trying to do is, so you can reach. So you can either go in one step or two steps. Here from here. So basically, how far you can move to the fifth element. So you can from here either you can take 2, which is 1, or 3, which is 2. So either you can basically reach from here to 1 to 2. This is either stair directly. You can go to stair 1, and this is directly you can jump to stair 2. So if you are at the stair number 1, if you are at the stair number 1, for example, what exactly meaning by that, I'll show you. So let's say these are the 2 stairs, these are the 3 stairs. So you can directly go one step. This is one way, or you can directly jump 2 stairs, right? Similarly, so if you have 5 numbers, right? If I come back, so you can directly go to one or step. So here, which means you can directly go here, or you can directly go here. So now if you come here, what happens? You again have option to go here like this, or you can go like this. Or if you for the first time you could directly come to like this, but you have two options again now. You can directly go like this, or you can go like this, right? So that's how it is calculated. So basically, for the first time, 1 or 2. Now you are at 1, which is you jumped here. Now you are at 1. You have two options. Either you can go to 2, or 3. That is what here is happening. If you see here, I can go to 2 or 3. If you directly go to step number 2, from here you have two options. Either you can go to 3 or you can go to 4. That is what here 3 or 4. and now you're at 5. So ignore this 5. So basically 5 is what the outcome is. Now you are at 2. When you are at 2, either you have option 3, or you can also go to 5, right? So you, either 3 or 4. When you're 2 at 2, either you can go to, when you're 2, either you can go to 3 or 4, and so on so forth. So basically the ways you can reach to the ways you can reach to the you can reach to the final top when the given n is 5. So that's the problem we are trying to solve, but you are using dynamic programming. How does this help is, basically what is recursion, difference between dynamic programming and recursion is, so when you are trying to compute this, right, here if you see here 2 comma 5, so from here basically what are the different ways you can reach from here, you are here, so you can 3, you can go to 4, you can directly go to 5, and so on so forth. So from here, if you are at 4, right, you can, if you are at 4, again you go out of bound. So basically you go beyond this if you take more steps. So basically what it says is, what dynamic programming says is, when you are computing this like this, right, when you are at here, you compute the same tree, entire tree like this, whatever you are computing, right, entire tree like this, you compute again this tree, same tree again here, 2 comma 5. So basically when you compute this, you keep, you store these values so that you don't compute here again. That is what it says. So if you see here 2 comma 5, this entire tree you compute again, right? So that's what it says. You don't have to recompute. If you see this tree, entire tree, and this tree, both are same, right? So you don't have to recompute this entire tree. Rather, you store these values, this value, and then use it. That's what it means. So this is copied from Interpret. This image is copied from Interpret. This image is also copied from Interpret. This is copied from Geeks for Geeks. So this is what it is. I mean, so let's understand one more time further. So what we are trying to do is, we are basically trying to claim the chairs, right? Claim the stairs. Claim the stairs. You have either one option, you can claim at once, or you can claim 2 stairs at a time. So if given n2, if there are 2 stairs, you can either claim like this, or you can claim like this, right? You can claim like this, or you can claim like this, or you can claim like this. There are 2 options. That's the reason there are 2 outputs. So don't worry about this. Don't worry about this as of now. So if n is equal to 3, you can claim like this. Go one option, one option, one option. All right, one option. The other option is you can claim like this, directly 2 steps and 1 step. This is the second option. The third option is you can claim 1 step and 2 step, 3 options, right? That's all the 3 possibilities when given n equal to 3. And when n equal to 5, so you can go step number 1, 1, 2, 3, like this, one option. You can claim like this 2 steps, and then 1, 1, 1, and then you can claim 1 step, and then go 2, 1, 1, and you can claim 1 step, grow again 2 step, 1 and 1, and so on and so forth. There are many possibilities. So how many possibilities are there? So there are 8 possibilities which are here, which is also been marked here. There are 8 possible ways you can go to the top. There are 8 possible ways you can go to the top, to the stage, right? That's what it is trying to say. So what dynamic programming says is, basically you're trying to store the intermediate values in middle. So we'll do in a reverse way. So let's say, instead of going from here, right? So we'll go in a reverse way. So let's say I am here. So what are the possibilities? I can reach to the same location only 1 step. If I'm here, I can jump only 1 step. So that's the reason it is what are the options I have at this stage? At this stage, only one. At this stage also, I have only one. If I choose 2 steps, there are 2 options, right? I can choose 1 step or 2 steps. If I choose 2 step, I go out of this. So at this stage, I have only one option. At this stage, I have one option. At this stage also, I have only one option. I can claim only one option. If I claim 2 steps, I go out of this. So at this stage, I have one option. At this stage also, I have one option. Now at this stage, what I have option is, I have one option like this, 1, 1, or I can directly go like this. So what I'm trying to do, when I am at here, for the first time, both are 1, 1. When I am at here, so basically I'm just combining these two output. I'm not recomputing again. I'm just combining these output. All I have to do is I just have to combine these output. When I'm at here, I just combine the last two output. So basically, when I'm standing here, I'm not computing. Imagine I'm not computing, but I'm just standing here. So to compute this value, I just have to combine the last two output. I don't have to go multiple times and then recompute. So rather, I just take what are the options I have from here and then I compute. I don't have to recalculate. When I'm standing at here, don't ignore this part, imagine it's not there. When I'm standing at here, what I have to do is, I just have to combine the last two output, how many possibilities are there, I'll get the output. When I'm standing at here, I just have to check last two output, which is this. So there are 8 possibilities, this there are 8 possibilities which I can claim, right? I can basically go from, imagine this is the option, right? When I'm at here, I basically, when I'm at here, right? When I'm at here, I basically combine these two, right? How, when I'm at here, I basically combine these two. So 3 possibilities. I can simply go and climb. There are 3 different ways I can climb the output. So let me know. You compute and let me know how it works. You try to draw this and then climb the stairs and let me know. So this is what the same output. The different ways I explained. The code is very simple. Code, what I'm doing is I'm basically trying to, so this is the code. I basically have to check the current pointer and the previous pointer. I start with 1 1. If you see here, the same code which is here. So the start with 1 1 1 1, and I'll just go through till now n minus 1, n minus 1, because I'm starting from 1. So I start with 1. Current, I'm trying to store it in a temporary variable. Let's say I am here. I am here, right? I am here. I'm trying to store current, this value, whatever the values I have. To compute this, let's say I'll try to store. I'll try to store in a variable. So current equal to previous plus current, which if I basically if I'm trying to compute current plus previous will give me the next element. This element will give me. If I'm here, current plus previous will give me this element. That is what the code is. It's very simple. And then I assign this value current plus previous. If I compute this, I'll go to the next element, but I have to assign this value to the previous element. That is what this previous element says. Right now, if I'm at here to compute this value, I'll combine these two, current plus previous. I'm here right now, but I want to compute this value, current plus previous. I'll get this value, but I have to have this value as well, right? So that's where the current value, whatever I have, I'll keep it in some other variable, and I tell them that this is the previous. When I move to this element, that is what this is doing, right? And then if you just debug this code and then understand this, I will not debug. Let me know. I've explained you in lots of examples. So basically, so this is the same code. Basically, if I'm standing at here, right, which is the current, I want to compute this value. So what I'll do is I'll do current plus previous one, which is this value, which is give me this value. But now I also have to, the current which I stored here, right, I have to mention this as a previous. That is what this code is doing. So please debug, please put a breakpoint, and then I've explained this in how to do debug in many examples. Let me know the output, and then this is the same code I have here. I'll just run the code. It's the same code I have, and also let me know why I'm subtracting n minus 1 instead of directly n. So you also let me know why I'm doing. So basically, I'm trying to store the intermediate value. Dynamic programming is simple, like there's no rocket science. We're trying to store the intermediate values instead of recomputing them. That's all. This solution got accepted. I hope you liked it. See you in the next video.